So now I'm about to give you some random exercises to build up your experience. So if you've been working through the videos, then you should have enough knowledge to solve what I'm about to give you. As I said, it's just a matter of building up your experience. So find the limit of this sequence as n tends to infinity. So will this sequence converge or will it diverge? If it converges, then find the limit of that convergence. So press pause and have a go. Okay, so to do this, have a quick glance. You see, this thing here is just going to oscillate between between negative 1, 1, negative 1, 1, negative 1, 1, negative 1, 1, and so on. This is just going to jump back and forth between negative 1, 1, and so on. So here, as n becomes very, very big, you're adding and taking away a tiny amount. Suppose n gets very, very big. Let's say 999999999, and then you take away 1. This one here is negligible. Or if you add 1, you're adding a tiny amount, which is next to nothing. So as n tends to infinity, visualize this thing here as being n. And then because you're taking away this tiny amount and you're adding on a tiny amount, and then as n tends to infinity, consider this as being n. So it's really like n over n, which is 1. So the limit of this, just by glancing at it, you can tell that the limit is 1. Or another way of doing it is to break this up into two fractions. One fraction here, and this is another fraction. So try doing this by just glancing at it. But then if you want to do it formally, then write it like this. Break it up into two fractions, and then use a squeeze theorem for limits to evaluate this bit here. Because this bit here is between, well, it's going to be negative 1, 1, negative 1, 1, and so on. This bit here is trapped in between 1 and negative 1. So now, so you can write, well, you could trap this between 1 over n and negative 1 over n. So now take the limit of all three. So the limit of this thing is trapped in between here and here. Then as n tends to infinity, this is going to be 0 because it's heading towards 0. So it's going to be trapped between 0 and 0. So this thing here is going to be 0. So this is going to be 0. So as n tends to infinity, it's going to be, well, this thing here is going to be 1. So it is 1 because this bit is heading towards 0. But try doing it by just glancing at this. So you've got one bubble over another bubble. As n gets very, very big, this bubble here is just considered, you're adding on a tiny amount, or you're taking away a tiny amount. Then consider this as being n over n, which is 1. The limit will be 1. So next question, find the limit of this sequence as n tends to infinity. So press pause and have a go. Okay, so to do this, use the same reasoning. So here you've got one bubble divided by another bubble. As n tends to infinity, this thing here, well, you're adding on a tiny, you're taking away a tiny amount. As n tends to infinity, this whole bubble here, you can consider it as being 7n. And then as n tends to infinity, you've got a tiny amount taking away of something that's very, very big, as n tends to infinity. So you can consider this thing here as being, well, you can forget about this tiny amount. It's just going to be a negative 4 times, well, it's going to be this. And then now, so take the limit of this thing here as n tends to infinity. Well, this here is a constant. This is a constant, so let's take it out here. So that will then give you this. So now it's just a matter of us finding out the limit of this. So now rewrite this as being n to the power of 1, n to the power of 1. So rewrite this as being n to the power of 1, and then over square root is really to the power of a half. So now it's 1 take away a half. That will be positive a half. So now if you look at this here, if you look at the graph, well, positive a half is really square root. So the square root looks like this. Square root looks like this. So now as n tends to infinity, you can see the square root of n will keep on climbing. It will keep on climbing. It will just get bigger and bigger and bigger. this thing would just get bigger and bigger and bigger. And then suppose, well, this thing is getting bigger and bigger, so it's like 9, a really big number here. So this really big number multiplied by this negative number is going to be a negative, very big number. So so if you get a graph plotter, well, the answer here is that this sequence will diverge. It will diverge. So if you get a graph plotter and plot y equals 7x take away 3, 2 minus 4 root x. If you get a graph plot and plot this, I don't know what will happen around here, but you should have something going to the negative infinity. So the sequence will actually diverge.